Hello, welcome to Math with Mr. Dobrescu, to the rescue. Negative exponents. Let's take a look today at negative exponents. Negative exponents indicate reciprocation with the exponent of the reciprocal becoming positive. You may want to think of it this way. Unhappy negative exponents will become happy or positive by having the base with the exponent pairs switch floors. And let me explain to you what it means. I have a cousin who is an apartment manager. She has actually several businesses, and she manages apartment complex for business owners. I think she has probably 100 units, and then she has probably over 200 employees working for her. And sometimes some neighbors who live on the second floor, they may be a little bit loud and unhappy. And then my cousin talks to the property manager, to that apartment complex manager, and informs that manager to communicate to that tenant or those tenants who live on the second floor who are unhappy, and then they communicate to them and moving them to the first floor, and usually with the hope that on the first floor probably they will become happy. Okay, and they do that, and sometimes he does. The tenants, when they move floors from the second floor, when they move to the first floor, they become better, they're a little bit quieter, and they become happy. Okay, and vice versa. If the tenants are on the first floor and they are unhappy, or the negative, think of that as negative unhappy exponents. If they're on the first floor, my cousin decides to talk to the manager again, to the apartment manager, and tell the tenant to let's move the tenant to the second floor, or the tenants to the second floor, with the hope that they will probably become happy. And in fact, sometimes they do become happy when they switch floors. So think of that when we work with negative exponents. Let's take a look at some example here today. Using that concept, the tenants, moving the tenants from the second floor, if they are unhappy, to the first floor, and vice versa. Let's take a look first of all at example 1. 29 to the power of 0. We've learned that yesterday, that any number raised to the power of 0 except 0 is 1. So this is a given, so this is pretty easy. The answer is 1. Any number except 0 to the power of 0 is 1. Let's take a look at example 2 here. Now here we have a negative exponent. We have 12 to the negative 1. What does it really mean in terms of first floor and second floor? Because right now we just have one floor, right? It looks that way. But remember that any number can be written as that number over 1. So let's put a 1 anytime we see a base to a negative exponent, a base raised to a negative exponent, we can put everything over 1. So now we create the first floor and the second floor. And now remember, the unhappy tenants or unhappy exponent, we switch floor, and then the exponent become positive. So let's switch floor. So 12 to the negative 1 now, we switch it to the bottom here, and it becomes 12 to the positive 1. And the 1 from the bottom is going to switch to the top, and 1 just stays 1. Only the exponents, when they switch, it becomes positive. So actually, this one, if this comes to the bottom, 1 takes its place, right? So the final answer would be 1 over 12 to the 1, or just simply 1 over 12. Okay? Keep that in mind. The negative exponents move to the bottom, and they become happy, they become positive. Let's take a look at example 3. Here we have 10 to the negative 4 times 10 to the negative 6. And remember again, we can put everything over 1, because we just have only one floor now. So let's create the first and the second floor. So let's put everything over 1, because 1 doesn't change anything, right? So we can put here over 1. And now we can see that those tenants or those negative exponents need to be moved to the bottom to become positive. And again, on the top here, 1 goes on the top, right? 1 goes on the top. It takes place of those negative exponents, and those negative exponents are going to move to the bottom here, okay? And let's see what we get. So here we get now 10 to the positive 4. So we have 10 to the positive 4. Let's erase that so we have some space. So 10 to the positive 4, this becomes, it goes to the bottom here, becomes positive. And then times 10 to the positive 6. Okay? They went to the bottom and they became positive. And now we know that rule. Okay? We have the same base and we are adding the exponents. So the final answer would be 1 over 10 to the power of 4 plus 6. Or we can say 1 over 10 to the power of 10. And this is our final answer. And if we want to get the entire number here, we multiply 10 times 10 times 10. 10 times or 1 followed by 10 zeros. Okay? Let's continue with example 4 here. Example 4 here, we have again one negative exponent or one unhappy tenant, which is going to move to the top, and that tenant or unhappy exponent become positive. So that becomes 3 to the power of 3. Times 1 doesn't change anything, so we just 3 to the power of 3, and 3 to the power of 5 stays on the bottom because that is already positive. And now let's see here. We have, how many 3's we have there at the top? We have 3 3's, and on the bottom we multiply 5 3's. 3 times 3 times 3 times 3 times 3. So using the extended form, we have here 3 times 3 times 3 on the top, and on the bottom we have 3 times 3 times 3 times 3 and times 3. We see in this case, if we subtract the exponent, we end up with the negative exponent here, because 3 minus 5, it becomes negative 2. So in this case, let's use the extended form for you guys to clearly see how we can simplify those exponents. So now we can cancel, simplify 1 3 from the top, 1 from the bottom becomes a 1, another 1, and another 1. And finally here we are left over with 1 on the top, right? Because 3 divided by 3 is 1. And on the bottom we have 3 squared. And because this is a small number, we can go all the way, and 3 squares means 3 times 3, which is a 9. So the final answer is either 1 over 3 squared or 1 over 9. I hope you guys are a lot clearer about how to solve negative exponents. You know how to solve negative exponents now. And remember, please, if a negative exponent is on the bottom, we move them to the top and they become positive. And vice versa, if they're on the top, we move that negative exponent to the bottom and they become positive. Thank you so much for watching again. And please don't forget to like and subscribe and share this video. And I'll see you in the next video. Take care. All the best to you.